Hereby, I open this academic ceremony in which Mr. Lu will defend his academic thesis, Cross-Linking Inflammation, Regeneration and Fracture Repair. I welcome you with your paronyms and wish you lots of success. I welcome also your supervisors. In the opposite corner, obviously the members of the opposition, whom you will meet later, and the audience on site and online. But before we start the opposition, I give you the opportunity to tell your family and friends what your thesis is about.
Thank you so much, Prorector. Dear Prorector, dear members of Defense Committee, dear supervisors, dear families, friends, and colleagues, good afternoon. With my great honor, in the upcoming 15 minutes, I will present the main results and findings of my doctoral dissertation titled Cross-Linking Inflammation and Regeneration in Fracture Repair. So, what is fracture? I think everybody knows it if we explain it without using medical term. So, fracture is used to describe a break or crack on a bone caused by, for example, trauma or other medical condition. And a failed fracture healing permanently can lead to another disease named non-union. And these two diseases leave a heavy burden on the healthcare system and impair the patient's life quality. So why is bone healing so important? Because bones can support the body, facilitate movement, bones can protect internal organs, produce blood cells, and store and release minerals and fat. So these functions are more or less impaired if the patient suffers from fracture or non-union. Therefore, clinicians try their best to investigate how to achieve bone healing from the different factors, for example, osteogenic cells, osteoconductive scaffold, growth factors, mechanical environment, and vascularization. And the clinicians are encouraged themselves to integrate it for these different factors into treating fracture healing and non-union based on so-called diamond concept. However, is it enough for investigating how to promote bone regeneration? I don't think so. Otherwise, in the world, fracture healing success rate will achieve around 100%, apparently not. It indicates that more other factors need to be investigated, for example, immune cells. So fracture healing is a very complex cascade involving different phases. And the first phase is inflammatory phase, which is characterized by the fracture hematoma formation. So what is fracture hematoma? Fracture hematoma is formed by the blood through the ruptured vessel. And within fracture hematoma, there are various kinds of cells innate, including neutrophils, macrophages, T cells, mast cells, etc. And the neutrophils are the first cell infiltrating into fracture hematoma to initiate the whole healing cascade. So what is neutrophil? Neutrophil is a white blood cell in human blood as the first defender. And in human, it occupies around 60 to 70% in human blood. And when the tissue gets the infection, for example, or damaged, neutrophil can fight against with bacteria or damaged tissue. However, during fracture healing, some studies say, oh, neutrophils play the positive effect on bone regeneration, whereas other studies say it is a bad guy. So it is still unclear the exact role of neutrophil in bone regeneration. A recent study in the field of oncology firstly described the two novel neutrophil phenotypes named N1 and N2. So for N1, it was defined as pro-inflammatory phenotype. For N2, it was defined as regenerative phenotype, like M1 and M2 macrophages, and maybe some audience already know. However, the involvement of N1 and N2 neutrophils in bone regeneration is still unclear. Therefore, in my PhD thesis, we first evaluate the effectiveness of the polytherapy and modern therapy in treating tibial non-union to point out that the insufficient investigation on immune cells, for example, neutrophils, during bone healing. And in next chapter, we reviewed the latest literature about neutrophils in bone regeneration and point out our hypothesis N1 and N2 neutrophils may present in fracture healing. So in next two following chapters, we investigate the presence and if so, the dynamics of N1 and N2 neutrophils in human fracture healing from their appearance to their function in the context of cathepsin D and G gene expression. And in the last two chapters, we investigate their direct effects on osteogenesis and endochondral ossification. Although the current standard golden standard for treating tibial non-union is still using monocyte, like take the bone from the patient itself and then implant into the bone defect site. So clinicians try their best to avoid to use it because there are lots of comorbidities. Therefore, as I described before, they integrate different factors into treating tibial non-union, which is named polytherapy in this chapter. So we compare polytherapy and monotherapy in treating tibial non-unions. And we found that polytherapy can achieve a satisfactory success rate, especially in more severe non-unions. So briefly, higher NAS score indicates more severe cases. And how to choose polytherapy or when we choose monotherapy. So we further analyzed the data from MUMC and we found that when NAS score achieves 48, clinicians can consider to use polytherapy for treating tibial non-unions. However, you can observe in polytherapy group, the success rate is still not 100% as I described. So we consider other factors to investigate neutrophils. And as also I described before, we evaluated the articles about neutrophil in bone regeneration. And we used the checklist online, and we only included the articles with the good quality. And we point out our hypothesis that N1 and N2 neutrophil phenotypes may provide new insights into the temporal changes that occur in the fracture healing with cytokine profiles and other cell populations that change rapidly over time. Therefore, we demonstrate our hypothesis. So we found their presence and dynamics in human fracture hematoma. So we isolate neutrophils from human blood in vitro and polarize them to N1 and N2. To identify a way how to get N1 and N2 neutrophils, we tested the surface biomarkers and also secreted molecules to make sure their properties. And we use the same properties to test the presence of N1 and N2 in human fracture hematoma by immunofluorescence and flow cytometry. And we found they do present in human fracture hematoma. And based on the data from flow cytometry, we calculated the ratio of N2 to N1. And we found that the ratio of N2 to N1 increases over time. And based on the definition of N1 and N2, it indicates a gradual shift from inflammation to regeneration. To further support this increasing ratio, we investigated two cathepsins, so cathepsin D and G, which are two key lysosome enzymes highly associated with neutrophil functioning during tissue regeneration. So cathepsin D acts like a scissor to cut useless proteins and to further recycle. For cathepsin G, it is like a weapon to fight against the bacteria or damaged tissue, for instance, and then initiate the whole healing cascade. Before we investigate from the human, we first performed bioinformatics analysis, and we found that in murine model, the gene expression pattern of cathepsin D and G different with each other. Then we moved to investigate in human fracture hematoma, And we found that the gene expression of cathepsin D increases over time, whereas cathepsin G remains unchanged. To contact N1 and N2 neutrophils, we found that N2 neutrophils express higher cathepsin D, whereas N1 neutrophils express higher cathepsin G. So these results support our findings in previous chapter of the increasing ratio of N2 to N1. And then we move to test their function on osteogenesis. So keep the same with previous study. We also co-culture between neutrophils and bone marrow mesenchymal stem cells. However, we also co-cultured between different neutrophil phenotypes with BMSE. We also got the same result, that unstimulated neutrophils, so in our case it is N0, can inhibit the early osteogenesis and later extracellular matrix mineralization. However, we found that N1 can prevent this neutrophil inhibitory on early osteogenesis, while inhibits cell viability. For N2, it prevents the neutrophil inhibitory on the extracellular matrix mineralization. To further investigate the underlying mechanism, we also test several osteogenic gene expressions and secreted molecules. And here is the example for the gene expression. We found that there is no difference between N1 and the N2 group. So this indicates that the different effects of N1 and N2 on osteogenesis may not through the genetic activity. But we found that N2 can promote BMP2 secretion for promoting bone healing, and N1 can inhibit MMP13, which can inhibit the extracellular matrix mineralization. This keeps the same result with what we found in previous slide. And last, we investigate their effects on endochondral ossification. So when we get the polarized N1 and N2 neutrophils, we wash them and we continue to culture them. We collect cell-free supernatant as the conditioned medium, and we use the conditioned medium to stimulate chondrocytes. We performed several gene tests and also other tests to support this gene expression. And here are the examples of the ALP activity and the luciferase assay to support this expression. We found that both N1 and N2 can steer chondrocyte towards bone rather than cartilage regeneration. And specifically, N1 contributes to chondrocyte maturation and subsequent osteogenesis. In terms of N2, it benefits for chondrocyte proliferation, hypertrophy, and maturation to offer a sufficient cell wall for the following endochondral ossification. So ladies and gentlemen, here are the main conclusions of my doctoral dissertation. So apparently, polytherapy is an effective approach to treating tibial nonunion, especially for the more severe cases. It is really necessary to investigate other factors during bone regeneration, for example, neutrophils. And both N1 and N2 neutrophil phenotypes present in human fracture hematoma. And we found that N2 to N1 ratio increases over time, which can indicate the gradual shift from inflammation to regeneration in fracture healing. The expression of cathepsin D and G can support this increasing ratio of N2 to N1. And we demonstrate the distinct effects of N1 and N2 on modulating the osteogenic behavior of bone marrow mesenchymal stem cells. And finally, both N1 and N2 can promote chondrocyte towards the endochondral ossification rather than cartilage regeneration. Thank you for your listening. Here I would like to appreciate everybody's being here or online. Especially, I really appreciate the help from my supervisors, Professor Martin van Grinsven, Dr. Taco Blockheis, and Professor Martin Poos. Thank you for your attention.
Thank you for a nice and interesting presentation. We will now start the opposition, and the first opponent is Professor Koenen, who is Professor in Biochemistry of Vascular Inflammation and Thrombosis at the Cardiovascular Research Institute in Maastricht. He's also the chair of your assessment committee, and he has also accepted the role of secretary today, for which I'm very grateful. The floor is yours.
Thank you, Mr. Prorector. Dear candidate, congratulations to you and, of course, to your supervisory team with this achievement. And I've really enjoyed reading your thesis because I have a lot of interest in neutrophils. And to warm up a little bit, I would like to start with some basic conceptual questions on the neutrophils before focusing on chapter 4 of your thesis. So, central in your work is the fracture healing and the function of neutrophils in there. And you also focus, especially in chapter 4, on the fracture hematoma. You write in this chapter that the neutrophils are supposed to be recruited, and you show that also in chapter 4. So you investigate this polarization, as you also discussed. So my first question is, are neutrophils in circulation already polarized into N1 and N2 variants?
Highly esteemed opponent, thank you for your question and thank you for your kind words. Based on my understanding, I assume that you ask whether they present in both fracture hematoma and also in blood, if I understand.
Yeah, if they already circulate in a polarized fashion in blood.
Actually, I was thinking through my PhD whether we can take blood from the patients to investigate whether both N1 and N2 present not only in local but also in the system blood. But I didn't do it yet. So this is what I'm interested in the future. But I do demonstrate that they present in human fracture hematoma. And in the part of this chapter, we polarize from the healthy human donor, so not from the fracture patients. And we just use some cytokines to stimulate outside and then keep the same properties.
So if you look at the donor plasma then, do you see any signs of upregulated markers that you use already? Did you check before you start polarizing that?
Actually, I didn't show the data in the thesis, but first, I just learned how to do flow cytometry. So I immediately to take the isolated neutrophils to the flow cytometry machine and I test by the 6 markers, CD15, 16, 95, 54, etc., 182. But only they express CD15 and 16. And this is what we show in the purity side, actually.
Okay.
Yeah.
Thank you. So can I ask you then, because you write on page 88 in your discussion of chapter 4, that N1 neutrophils, by the factors that they secrete, for example, interleukin-8, they attract N2 neutrophils. But how can they attract N2 neutrophils then, if there are at least not a clear evidence that N2 neutrophils are already circulating in circulation?
Because neutrophils will infiltrate into the fracture hematoma from the first several hours until, they say 7 to 10 days. Okay. But we don't know how they can exist. But we first, you can see that we collect the samples from the day 4 and to day 14. So I assume they will present in fracture hematoma within 2 weeks. And for attracting I think future study need to track it. But this is also our, our future perspective, like how the exact interaction between N1, N2, and the macrophages. Yeah.
Okay, so let's assume that the neutrophils polarize within the hematoma. Let's keep that. So they are recruited and then they polarize over there. What are the physiologic factors, for example, that polarize towards N1? Because you use in the lab, you use LPS, which I hope is not present in the in the closed fracture. So what do you think polarizes the neutrophils inside the hematoma towards N1?
We not only discuss it in chapter 4 and also in the review, chapter 3. Like at the beginning, I thought N1 neutrophils can secrete, for example, interleukin-8 or TNF-alpha and to attract other cells, macrophages. But what we are interested in is that whether it can attract the other phenotype of neutrophil N2, for example, and also BMSE. That's why we also tested the SDF1 alpha. But for the exact mechanism, like we didn't track it, so I cannot really say it, but just our thinking and what we do in the future.
Okay.
Yeah.
Great. So if you're talking about the future, I may have a tip, which I connect to a question or a hint, is there are a lot of blood platelets in hematoma. Because blood contains a lot of platelets. And platelets are also full with interleukin-8 and SCF1 alpha and DAMPs maybe even. So would it be an idea to look at the platelets, and do you actually need polarized neutrophils to attract other cells? Might not the platelets be good enough already to do this job?
It's very interesting, and honestly, I didn't think about the platelet, but I just think about the interaction between different neutrophil phenotypes with macrophages and also with the bone mesenchymal stem cells. And we also co-culture, but we didn't do the transfer, how to track, and also in the murine model, etc. But for platelet, yeah, I didn't think about it, honestly, because I think, in my view, macrophages may be more interested in, because it can take over the inflammatory and the regenerative from neutrophil. That's why.
Yeah. Macrophages get all the attention in science, I know, and then maybe the neutrophils. So, yes, thank you for that answer. So, I was wondering, you're talking about the fracture hematoma, and everybody, I hope not everybody, but I at least, as a child, bumped my head a couple of times, and I had a bump there, which is, I assume, also a hematoma. What makes the fracture hematoma different than the normal hematoma? And you say, okay, you have a polarization, you see N2 cells probably increasing by the ratio. Wouldn't you see that also in a normal hematoma that you get if you come with your hand between the door, or you bump your head? Is there a fundamental difference? Sorry.
About the detail, for example, pH or other cytokines or the concentration, I don't know between the fracture hematomas in different sites. But I do believe that the fracture hematoma is very important because first, it is formed, and then lots of interactions happen, and it will become the soft callus from time to time, and then become the hard callus, and in the future, it will be remodeled. So that's why fracture hematoma, the function, briefly, they are same in different fracture sites. I don't know, there are so many professors,
the question
but in my
hidden
view,
behind this question was whether you need bone in the hematoma.
No, we just choose the long bone. So, we just choose the long bones.
Yeah. I have one short question, if I may.
Short question, short answer.
Okay, so I look at page 85 at figure 6. And then you have this very nice correlation between the ratio and the time. You also showed it in your introduction talk.
Sorry.
What happens at time point 0 with the ratio? And what does time point 0 tell us if you extrapolate?
It's a very nice question. I mean, this is if the temporal 0, I assume that when patient suffered from fracture, unfortunately, he will immediately receive the surgery. But I don't think it is not the professional way, because some open fracture instance, we need to control the infection or etc. Or some closer fracture, we still need to wait a bit. That's why we cannot decide, like, patients, you need to do the surgery on day 1 or day 2. So that's why,
Now, if you look at time point 0, your ratio is negative. That's and I just wanted to know what that was physiologically. But thank you. I'm very happy. Thank you also, Mr. Prorector, for giving me some extra time. And I give the word back.
Thank you very much for your opposition, Professor Koenen. Now we go to the following opponent, who's online and also a member of the assessment committee, that's Professor Leeuwenburg, Professor Bone Infections in Dentistry in the Radboud University in Nijmegen. And thank you, Professor Leeuwenburg, for coming all the way from Nijmegen, albeit online. The University of Maastricht is always very glad to have people from and guests from outside.
Yes, thank you very much, Mr. Chairman. Dear candidates, first of all, I would like to congratulate you and the team of your supervisors with the completion of your thesis. I've really read your thesis with great interest and also admiration, actually, because I think the topic is very relevant and under-addressed. So neutrophils are not addressed very often, so I think you did a great job there. The thesis is very coherent. And in doing so, you contribute really to bridging the gap between clinical and basic science. So that's worth the compliment. Of course, my task today is different. Good science raises good questions. And I would like to have a few of those discussion points with you right now. So about the questions and hopefully your answers. So I'd like to warm up with you in chapter 2, so where you compared poly versus monotherapy. And as a biomaterial scientist, I was very happy that the polytherapy, which includes also the use of biomaterials, was the winner, basically. More beneficial outcomes for polytherapy. But then, as a biomaterial scientist, I was also wondering, is it then the biomaterials or the factors or the cells? You still try to know more, but can you tell us more about the different role of the various components of your polytherapy?
Esteemed opponent, thank you for your kind word and thank you for your questions. And we choose polytherapy is a strategy, so not focus on each element, because it's really hard to perform only BMSE in every patient or only any material. That's why we need to make sure there is no unhappy thing will happen after the treatment. And sometimes we choose to perform for example, the RIA or from the other cell resources. And sometimes we go from the effector, and we also go the bone flow, if I remember correctly, because my supervisor do a lot of this surgery. So to standardize this, that's why we define that polytherapy is that we at least use 2 categories of them, and monotherapy the maximum 1. But I mean, it's interesting if we only focus one product or material, but now for clinic, we just compare the different strategies. So at least we can offer a nice treatment to patients. So, yeah.
Okay, so I understand you would like to offer more tools to stimulate regeneration, so at least 2. But then still I will play devil's advocate for a couple of minutes longer. So out of those 3 components, which one would you, as a future clinician, choose? Would you then go for cells or for factors or biomaterials, or the more the better, so combining actually 3? Do you have any preference? And I'm not asking for sound scientific evidence yet. I understand it's complicated, but for your future occupations, how would you like to proceed?
Background is still clinicians, but I just a PhD student to collect the samples in surgery. And when I observed what my supervisor Taco Polakai stated, I feel that, sometimes I can receive the RIA, sometimes I can receive the BMAC, or sometimes I can receive both. And for material, I also learn a bit, like I mentioned before. He used the effector and sometimes use TCP or bone flow or other stuff. So, and I included this data, and during I recording the data, I can feel that polytherapy is really nice, because I also got fail of monotherapy fail, and afterwards these patients need to receive 1 more surgery or 2, etc. So I will recommend this strategy, not the only single factor. Yeah.
Okay, so sometimes maybe you're familiar with this expression, less is more, but if I understand your data correctly, in this case, it should be more is more. So more components result in better clinical outcome.
Because the limitation of polytherapy is money. So if we have enough money, let's just do polotherapy in each patient. Unfortunately, it is not. That's why we analyze it and offer a strategy when we choose polotherapy, when we choose monotherapy. Of course, we need larger cohort research work on it, not only the 40, I think, included in my chapter 2. But this is a sign, I think.
Yeah.
So, yeah.
Thank you. Yeah, that's a convincing answer. So now I'd like to move a bit more into detail in chapter 6, where you developed a nice co-culture model. You combine neutrophils with stem cells. But I was wondering, is it really a co-culture model? Because you tested the viability of your stem cells, depending on the availability of neutrophils, but that was performed after 7 days when you already removed all of your neutrophils. I'm just generally wondering, where do these neutrophils stay? They are in suspension, but do they survive, or how do they affect the stem cells that are adhering?
So we established this co-culture model based on a previous study, actually also another PhD student in our team. And we also get the same result. For the co-culture system itself, neutrophils are suspended cells, which we can completely wash off. And in my very, very first case, I do a small test like echo culture, and after 3 days, I wash them out. And then my supervisor suggested me to do, for example, MGG staining, main ground GIMSA staining, to show. And I observed that there is no neutrophils left. So that's why I believe that is the nice co-culture system.
But then just to go a bit more in detail here, like, did you test the viability of the neutrophils you removed? Do you remove viable neutrophils, or are they already sadly gone and passed away?
We don't test the neutrophils viability after 3 days. We just wash them off. But we do keep the concentration before establishing co-culture.
Yeah, maybe that's a recommendation for future research, to check if they are still viable, and if so, how metabolically active they are, because they might secrete more or less cytokines, for example, depending on their polarization. So, and generally, like, that's more a philosophical question. I don't know the answer either. But so if you try to model clinical reality, the physiology. Then you explained in your introduction that the neutrophils arrive first, one of the first arrivers in a wound, and then they attract stem cells. So wouldn't it not be logical to do something similar? So first culture the neutrophils in suspension, and then add the stem cells, so that you create a conditioned medium?
Because mesenchymal cells is adhered cells, so we need to take time to seed them inside. And we just focus on the stimulating time, for example, and not who culture with each other. So this is what we think. And we only stimulate for 3 days and test in the following days. So we can easily observe how different effects of N1 and N2 on osteogenesis. Yeah, so I cannot really repeat what it exactly happened within fracture hematoma, but we do first to open the door for this whole field of N1 and N2 neutrophil phenotypes in bone regeneration, because it's a new definition. So that's why in the future we will not only do the co-culture but also do the transwell, or maybe track them within fracture hematoma and also in vitro. And I also have a small answer of your last question, actually, because I'm also interested in the immune modulation of MSC on neutrophils. Then we can test the cell viability after co-culture and also examine their cell surface marker, because I have impression one article described the influence of MSC on neutrophil phenotypes, but I don't know how it happened.
I'm very glad with your answers, and I return the word to the rector. Thank you.
Thank you, Professor Leeuwenburg, for your position. Now we come to the following opponent, who's also a member of the assessment committee. That's Dr. Pastor. She's Associate Professor at CBITE Spatial Omics for Regenerative Medicine Group in the University of Maastricht.
Thank you, Rector. Dear candidate, I would like to congratulate you, of course, and the supervisory team for this very nice piece of work. also with several publications and still a couple of chapters to be published, so congratulations. I would like to start with chapter 2 and again come back to the discussion of poly versus monotherapy. So you have made these two categories and you have compared the outcome of patients when they have this mono versus polytherapy. However, this group of polytherapy is quite heterogeneous, right? You have this MSc, TCP, different treatments. And I was looking into the thesis, you have this very nice table where you show the demographics, table 1 and 2 if I'm correct. But there is no really data on actually what patients received, or which patients received this or that particular therapy. Can you elaborate on that? Because I do think it's a very relevant information to be included.
Highly esteemed opponent, thank you for your kind words and really thank you for your questions. We included the patients from MUMC and divided them into the different groups. I mean, this is a kind of retrospective study, so we cannot already not decide who kind of method they already received or not. That's why we just record what they already received, and then to show these two populations has no statistical difference between each other to further support this rationale, and then we go into the comparison between different strategy. So I was wondering if, yeah.
But let's say that you have now the power of designing again the study. Would you perform exactly the same type of study, or would you take into account other factors?
I'm sorry, I don't.
Maybe I can help a bit.
Yeah.
Let's say, since we discussed, right, that the polytherapy group is quite heterogeneous, don't you think that perhaps subgrouping the different patients based on the specific treatment they have received, right, the different combinations of different therapies, let's say, do you expect that you would get exactly the same results, or perhaps if you subdivide these groups, maybe the outcome is slightly different? So I don't know, for instance, what's the percentage of people getting MSCs? I can imagine it's quite low. And other treatments actually have a much higher percentage. So we are looking maybe at the outcome of one of those particular treatments being more prevalent. But yeah, I'm not sure. Maybe you have more information about that.
Actually, I really downloaded as much as I can. And another difficult thing is that they're all Dutch. So I translate into English first and then discuss with my supervisor, and we try our best to include the patients what we have already from 2014. So that's why I think, and another thing is that we included at least around 20 cases in group. So I think it's fine. I mean, for non-score maybe needs more patients, but for comparison the treatment outcome, I think it's good. Another reason is that we also standardize these patients by NAS score, and which includes different covariants. And then we also published before that this is the rational score to standardize each other. And for the outcome, we also use another score named RAS to do to quantify the outcome. So I think,
Okay, thank you for your answer.
Yeah.
Now I would like to move to chapter number 4, where you do this characterization of N1, N2 phenotype, focusing on, I believe, 3 to 4 markers per cell type. And then you claim that you have these different phenotypes.
Yeah.
Do you think that's enough, having 3 to 4 markers to really talk about a phenotype?
So first, this is a really new field, and we just we read lots of literature and keep the same with what other studies use. That's why, so first, the CD15 and 16 is a marker for the neutrophils, and based on that, we choose 54 and 95 for N1 and 182 for N2, which keeps same with the original study. And in 2009, they also defined these markers as N1 and N2, but there are several studies use other markers, as you mentioned. So for example, CD184 and 206 for N2 neutrophils. However, to further show they are N1 and N2 neutrophils, we further tested the secreted molecules by ELISA. That's why we confirm that they are N1 and N2. And the following chapters with the co-culture can demonstrate back that they do N1 and N2 because of their different functions and keeps in line with the original definition of their function. So I do believe that they are N1 and N2 neutrophils.
But is it really like a black and white situation? Is there maybe an intermediate state or something like that? I'm thinking about in vivo situation.
Yeah, I'm also interested in it as well, actually. That's why in the future I would like to investigate. But in our another chapter, like chapter 7, we further cultured N1 and N2 neutrophils, but just with the normal medium, not with the cytokines innate. And we continue to culture for 24 hours following, and we see N1 neutrophils still keep higher CD54 and CD95. But N2, it will keep the higher CD182 on 4 hours and also 8 hours. But afterwards, the CD182 goes down. Mm-hmm. So that's why maybe, I mean, we also, maybe we really need to do research in vivo. But I think in vivo, there are already some cytokines, or like what I mentioned, the immune modulation of MSC on neutrophils. So maybe other cells can also influence. So we can, for in vitro so far, we cannot really repeat what exactly happened in vivo, but it really deserves to investigate. So.
Yeah. And can you think about let's say a technology that you could use, let's say, to profile these different stages, in a more untargeted manner? Because so far it's pretty much targeted, all the analysis that you have performed, also based on literature and the classical M1, M2 classification. Can you think about perhaps a different way of exploring and creating perhaps more diverse panels, protein panels for these categories that you were describing?
Yeah, because now I finished this dissertation to show my view, but other studies also insist their surface biomarker. So I think we need to test more from the function side to further support the rationale of these biomarkers. Not only, why do I choose this biomarker? And then, like as I mentioned, the first definition of N1 and N2 is from this function. So as I know in our team, we will follow in to test for example, ROX and NAS, etc., for further support N1 and N2. But from my side, I do believe they are N1 and N2. And I mean, after my PhD, I will investigate more. But before that.
Thank you very much. Do I still have time for one question? No. Okay. I give the word back to the director.
Thank you, Dr. Pasta, for your position. Now, the following opponent is also a member of the Assessment Committee, that's Dr. Wieten, and her expertise is transplantation immunology in the Maastricht University Medical Center.
Thank you. Dear candidate, I really want to compliment you with an excellent presentation. It was very clear and very well done. And I also want to compliment you and your team, of course, with a very interesting book. And like you already mentioned yourself, you investigated something that is relatively unexplored yet, potentially very important, and at least it gives a lot of new ideas for follow-up research, and you already showed some examples of that. I'm an immunologist, and I think your thesis and also the discussion really tackles a very important topic for many immunologists. Is how can we make sure that we if you think about pathologies, that we engage immune cells in the right way, in the right place, and if we know what is the right time in the right place, how can we perhaps do some therapies with immune manipulation to, if the balance is destroyed, that we can restore it. And I'm very interested in, as a first pretty general question, knowing from you, if you look at the neutrophils, do you primarily see them as drivers or as facilitators of healthy bone healing, or do you perhaps see them more as bystanders? What is your thought on that?
Highly esteemed opponent, thank you for your questions and thank you for your warm wishes on me. This is a very interesting topic because based on my clinician background, I'm also interested in how to achieving the research work on really treating the patients. Because in 2009, this was first described in the field of oncology in my introduction. So in the field, in the bone regeneration field, it is almost empty. So that's why we first need to present, they present in fracture healing and also their functions. But for the future treatment, for example, how to modulate the immune response locally or systematically, or how to insect, for example, some materials to modulate this local neutrophil. I don't know yet, but I'm really interested in it. And I also have one impression that there is one study already mentioned one material that can modulate neutrophil phenotypes, but they don't define them as N1 and N2, but they show the same biomarker. And also, not only through the interaction between N1 and N2 neutrophils, but also through other cells, all promote the angiogenesis, for example, and then further promote the bone healing. But for the retrospective study or prospective study, for example, take blood from the patients and then we found out a marker, we can predict how fracture healing outcome and we can take some reaction on time. It is my dream, but it's still needs time. Yeah.
I understand. And there's a lot of work to do, and that's good because then we need scientists and clinicians that can do it. But what do you think? At least reading your thesis, I was thinking a bit like the neutrophils come in very early, right? But they also have a very short lifespan. So how important is their interaction with other cells? And if you think about healing that is not going well, can that be because of the neutrophils, or do you think it's more something else that influences the neutrophils and that's why it's not going the way it should go?
Yeah, so like I said, MSC can influence the neutrophil, but neutrophils arrived at the beginning. So maybe other cell populations and the cytokines can influence the neutrophils. This is, I do believe, but I didn't investigate it yet because it's really hard to create a fracture hematoma in vitro, and we know every details. So yeah, I don't know yet, but really interesting. I'm also interested in it in the future.
Yeah, and I understand it's difficult to study that in vitro because there's partly overlapping mechanisms. But one of the things I was thinking about, you have in chapter 4, figure 6, the N2 to N1 ratio. I think my opponents already discussed it briefly with you. And there you show that over time there's an increase in the ratio. So there seem to be more N2s. And my question is, by flow cytometry, you look at the relative abundance of these cells. Did you have the opportunity to look at absolute numbers as well? Do you know whether there's really in absolute numbers more N2 over time?
I did observe the exact number of how many neutrophils left. Is not really a lot around. It really depends on the date of the fracture hematoma. For example, I have an impression, but not sure yet, around 8 days fracture hematoma, only around 1,000 left. But from this size of fracture hematoma. So normally we make the cell suspension and put it into the flow cytometry immediately, and we gate, but the exact number is really low. Yeah.
Yeah, okay, because it can always be that the two fractions, relatively speaking to each other, change, or that there's, for example, enhanced recruitment of neutrophils, and that's why the fraction changed. And that could be already a nice start to investigate this. I'm also, that's a bit more general question following up on this. Do you think a role for neutrophils in non-healing fractures, is that more a matter of too little inflammation, so not enough N1 capacity, or is it that the switch towards N2 and more the repair and the remodeling type isn't going well enough? What is your thought on that?
It's very interesting because I was also keep seeing about this question. If I am the designer who make a material, how can I modulate, just convert from N1 and N2? But after thinking and thinking, I don't think so. I mean, we can towards this way, but we still need to keep a balance of the inflammation response. Because in my chapter 3, the review, I say that the over inflammation or immune response or the less is bad for tissue regeneration. So I would do the modulation from N1 and N2, but I will keep there in some number. But I don't know, but I assume that because in the field of oncology, N2 is bad. It is regenerative role, but it can promote the tumor. So if we use it into the bone, I'm not sure whether some cancer happen or etc. That's why we really need to do more research work. Yeah.
Can I have one more? No. Thank you very much. I'm really happy.
Thank you very much for your opposition, Dr. Wieten. Now we come to the follow-up opponent. That's Professor Bloemers. And he's professor in the Trauma Surgery Institute in the Amsterdam University Medical Center. And I thank you for coming all the way from Amsterdam.
Thank you, Mr. Prorector. Dear candidate, first I'd like to thank you and the promoters for the invitation to come to this beautiful Maastricht. And compliments also from my side for the clinical and moreover the basic science in this thesis. Your promoters are well known for their knowledge on fracture healing, but of course I have several questions to be answered as well. And let's start first with chapter 2 also, with the poly and the monotherapy in non-union. I'm not sure if these groups are really comparable. For example, age. When I look through table 1, the age of the polytherapy patients are 47, and in monotherapy they're much older, 60. Can you explain, is this not a confounder?
Thank you for your question. I mean, the p-value is 0.06.
Yeah, 0. Yeah, okay. Yeah.
I also think about this question, but
it is the answer I expected. But if we had some more patients,
yes, I do really would like to include more patients and keep them more close to each other. So please receive more patients to treat.
Yeah. A more important difference might be, I think, the severity of the injury the patient sustained, because we all know that neutrophil, we don't all know, but I know it now since I read your thesis, that the neutrophils are very important in inflammation phase after severe trauma, and there's really an explosion of neutrophils in blood after severe trauma. And in trauma surgery we use the injury severity score. Can that be the confounder? I mean, so if you have patients with much more injuries, because that's not in the NUS score embedded. If you have severely injured patients, they have an explosion of neutrophils, and that drops after 8 days, and then you get more infections if you do surgery. But is this not a confounder in your study?
Yeah, this is about the preference. So for myself, I prefer to choose the NUS score because it includes, not includes the time of injuries, but it includes the time for surgeries and also some sign for inflammation. I do consider about it. And there is another article in our team already demonstrated effectively that NUS score is a reliable score to
maybe also because it's, sorry for interruption, but maybe because also after injury, so people are recovered in both groups from the severely other injuries.
Yeah, it can happen, but this is what we normally do at the beginning when we receive the patients, and then we perform the NUS score, and then we make the strategy to treat. But yeah, I agree with you, but yeah, we rely on NUS score.
And also another question is for the bone defect in the non-union. Was that comparable? I can imagine for monotherapy.
Yeah.
And I think monotherapy, you only put autologous bone in the defect.
So
But were the defect sizes comparable?
I didn't compare the exact size of the bone defect between two groups, but when I recorded the data, I can feel that the bone defects in polytherapy group is more serious. But this factor is included into the NAS score, which we use the NAS score to standardize everything. Yeah.
Is there any place for monotherapy? Is there any place left for monotherapy?
The plate?
Do we?
Plate, yes, but for the materials for promoting the bone healing.
Only when the NAS score is low, below 48, you can perform monotherapy.
I mean,
that's one of your conclusions, I think.
Yes, I do. From scientists, yes, but from the exact, we need to communicate with patients. Like, we would like to choose the monotherapy for you. So, but they need, if they have money, they maybe choose polytherapy. But if they are same, I mean, we will suggest them, let's try monotherapy, but still a risk. Maybe it's still a failure further. Yeah. But this needs the larger cohort retrospective study. So this is just a sign.
Okay, thank you for that answer.
Yeah.
Then I would like to go to chapter 3 in your systematic review on neutrophils in the databases. You only use PubMed, which I don't think is a database, it's a searching machine on Medline, but okay. Would you do it a different way the next time? Because there's only 400 articles in the beginning.
Because PubMed
it's big, but you have more databases.
For other bases, I mean, it is a limitation of our review. But the reason why we only use PubMed is that it is specific to clinicians, of course, scientists as well. But for us clinicians, we focus on their influence on the future clinical transfer, not only for research. That's
why you also choose for 10 years.
Exactly, yeah.
But you then missed some articles of me, and especially from Professor Blokhuis.
Okay, sorry. So it's time to write another review.
Yeah, exactly. Let's do it together, okay? And one of your conclusions is, or one of the conclusions of the systematic review, that day 7 and 9 is very important because then the infections raise. Is this really have a clinical consequences? Do we have to stop treating, or do we have to do surgery within a week? Because the data show also in the other chapters that there's something happening around day 9, day 7.
Yeah. I mean, this thesis is just open the door, like tell the clinicians they both N1 and N2 present, and then they're valuable, but it cannot be the standard, golden standard yet. So we need more research work.
I don't take that for an answer. We do not because you did a lot of research and you did systematic review, and we know about in the science that after day 7, day 9, the neutrophils go for inflammation to regeneration. Mm-hmm. So that's the sort of line we have to act before that, otherwise we're missing the inflammation capacity.
Yeah, but not only neutrophils cause the inflammation. So we need to think about more other factors, for example, macrophages, that is. Yeah. That's why if we would like to solve the problem in clinical, we need to know the whole field first. Otherwise, it's a risk to destroy patients. So I cannot say that,
can you think on, sorry for interrupting again, because one small question. Can we modulate the stress response by corticosteroids, for example?
You may answer the question. You may also say enough is enough.
I would like to discuss with a highly esteemed opponent. Really interesting topic. I mean, it's enough to open the field, but not enough for the clinical treating. This is what I can promise you. But if I say, you need to treat in some days, it's like it's not reliable. So we need to be scientific, and then we can really treat patients. Yeah.
Thank you, Professor Bloemers, for your position. Dear candidate, Mr. Lu, the time appointed for the defense of your thesis has passed, and the degree committee will now withdraw to discuss the quality of your thesis and the way you defended it. And I request that you and your company on site and online await the results of our deliberations and our return to this room. With that, I suspend the meeting.
Please all rise.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. On the line, I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. And even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. To the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and that. What's on the line? I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile.
I reopen this ceremony. Mr. Lu, the degree committee here present has assessed the quality of your thesis and the way you defended it. And in view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Dr. Blokhuis is authorized to confer upon you this academic distinction in accordance with Dutch university custom. And I invite your supervisor to now take the floor.
Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent and responsible?
Yes, I promise.
By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Fangzhou Lu, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary and the other members of the committee and affixed with the official seal of the university.
Dear Dr. Lu, or how you say in Chinese, Lu Doctor. What an honor to be the first one to call you like this. Your journey from China started some days before December 1st, 2020, the starting of your PhD and in the middle of the corona epidemic. You had contact with Taco via Zoom, and you asked for a PhD position, and Taco said, you speak reasonable English, you seem to be a good guy, so what do you think? So he came to Martijn and me, Martijn and Martijn. Yeah, we spoke and we decided we would go on this adventure with you. And an adventure it was. Taco and I have always had an interest in granulocytes, Martijn more metabolism. And Taco also had a passion about N1 and N2. So that became your theme. And everybody knows now, after today, very well about N1 and 2, as you are a great advocate of these granulocytic subtypes. After your arrival, you really had to get acquainted to the new Dutch culture you were immersed in. Things are different, but we must say you have become quite Dutch, actually, on your bike. The lab environment was completely new for you, being a medical doctor, but you were eager to learn. Sometimes a little bit too eager, and you know very well what I mean. I had a protocol to isolate granulocytes by hand. You were very grateful and excited when I came with you in the lab to show you the isolation in the cell culture hood. And of course, you made 100 pictures to capture the moment of us two in the hood. And yes, I'm seldom in the work lab anymore. But with you I did. And the little ring you needed to pipette was difficult to see and you struggled with it. But as always, you found a solution and you came to us and said, you know, it's much better the Max system. And then it's very high purity. And indeed, you obtained 95% pure granulocytes. So you start using that method, yeah. And you optimize then also the differentiation protocols for N1 and 2. And you set up a standard, and that is used in our research group, in the trauma, and in our Merlin group together. You have that as a standard. While the lab work needed some time to start up, you, as a medical doctor, also started together with Taco and Martijn in the outcomes of mono and polytherapy for non-union fractures. That is per se quite a task. However, and you already mentioned it a little bit in one of your answers, we are in a Dutch hospital and the patient files are in Dutch. You do speak 4 words of Dutch because I have heard you said goedemorgen and dankjewel. But this was not really enough to fluently read the files. However, you wouldn't be Fangzhou if you would not come up with some fancy solution to translate and understand. And finally, for that paper, you had to deal with a crazy Italian editor, right, Taco? Yeah, which robbed your and Taco's night of sleep. But at the end, a very nice study came out and was very well published. Then things got a little bit crazy, and you could not work in the lab for some time. But what I admire about you is that you came to me after that time, when you came back in the lab, and you said you felt you had grown and really understand to be a good lab person. And I must say, Fangzhou, that shows your maturity and self-cognition. And just this morning we spoke with the lab managers, and they all said that they were extremely happy how you really boosted and became really a very good lab citizen. And that, with that attitude of yours, you did earn a lot of respect. And you understood that one can make mistakes, but deal with them and learn from them. And then it really touched me to read your 10th proposition. Don't be afraid to make mistakes. And I may add today here another saying that I use a lot. Everything in life happens with a reason, even though you may not see it immediately. So from that moment on, results started flowing in and you started putting them together. And the three of us, Taco, Martijn and me, took you to several conferences where you gave poster and oral presentations, and we were very proud of you. And we have that all recorded in pictures, of course, because we are almost Chinese. And you bought especially a chic suit for that. I have heard that you also spent some crazy nights with Raalt. I do not have all the details, and perhaps it's also better, yeah? But I know that the two of you, yeah, spent some nights sleeping in the car after coming out in the bar in Amsterdam, yeah, and then getting up early to make it in a rush to your presentation without showering. But in the evening a man, in the morning a man, right? I would also like to refer to two more personal things. You invited us one time to your apartment for a real Chinese meal, and it was really an honor to us. You made a meal with more than 10 different dishes, which you really cooked yourself. And then when we came in, wow, we thought, wow, this is an entire army he is going to feed. And I do not drink alcohol, as you know, and you respected that, but you had a special baijiu, I think it was called, both from your home country, and Elizabeth needed to drink it, and it was quite strong. She said it's much stronger than the Cuban rum she was used to. The second thing is that you started to play the violin. You rehearsed, and you showed it us on your phone and all your rehearsals. And after the first paper you published, you came in the office. Martijn, Taco and me always have on Mondays, or at that time also on Thursdays, a meeting. And then you came and you played a special song by heart to me, Martijn and Taco, as a token of appreciation and celebration. And that really was very nice for us. In your personal life, at that time, everything started to shine as well. You met a scientist from Oxford, and we're going back and forth. And there she is now, proudly sitting. And in the meantime, actually, you can call her your wife. Shen, I also extend my congratulations to you as well. And I know you have been there for Fangzhou and supported him in the last stretches of his PhD journey. And I was honored to receive beautiful pictures from your wedding in China. Thank you. Now comes the difficult part. Wo ye yao qiang ni de fumu biashi shu he. Nimen yin yao wai zi de ersi guandai yao wao. What I mean to say is that I also would like to extend my congratulations to the parents. You can be very proud of your son. I know my Chinese, my Mandarin is not so good, yeah, and I may not get the second and third plums, but I hope you did receive my congratulations. Also on behalf of Taco and of Martijn, I wanted to thank the members of the assessment committee, Professor Rory Koenen, Professor Sander Leeuwenburg, Professor Jan-Willem Metsemakers, who couldn't make it today, Dr. Berta Celero Pastor, and Dr. Lotte Wieten, for their willingness to read and positively assess the thesis, and for coming here today for the defense. That also includes Professor Bloemens, who is a member of the Defense Committee and came all the way from Amsterdam, and he said already to the nice Maastricht. Our gratitude goes also to our teams from the Trauma Department, from the ERB MVG Group, Seabite and Merlin, as well to Erik Wijnands from the flow cytometry lab, with whom you spent a lot of time looking at all those cells. Dr. Lu, Lu Doctor. A new chapter is about to start in Beijing, where you will start your education as a spine surgeon. Let's see how the granulocytes play a role in the spine. We, Taco, Martijn and myself, wish you all the success for this new start and a lot of happiness in your life. Congratulations again.
Thank you, Professor van Grinsven, for a beautiful laudation. Dear Dr. Lu, also on behalf of the University of Maastricht, I congratulate you with the degree you have acquired, and I hope you have time to celebrate it, and I hope for you that you have a wonderful career and a good future. I would like to extend my congratulations to Dr. Blokhuis, Professor van Grinsven, and Professor Poese, and of course to your wife, your parents, family, friends, and colleagues on site and online. I'd like to thank the members of the opposition for their work and for coming to Maastricht, and of course the PEDEL and the technical support team who made this hybrid ceremony possible. Having said that, I'm about to close this ceremony, but what we'd like to do is make a picture in this room with on the background Professor Leeuwenburg. So I ask the audience to already go to the rafter where the reception is, and the garden. I think it's beautiful weather. And then if we have made a picture here, we go to the foot of the stairs in the hall where we make a second picture, together perhaps with your wife and parents. And then we come to the reception. And if you think, when can we congratulate the young doctor? That's quite easy. You wait for us, we go first, and then you come. So it's quite simple. Having said that, I close this ceremony. Come forward, come forward, come forward.